Okay, before starting each one of these problems for the study guide, I want you to know that I'm going to use each of the diagrams that we've used in class. I'm not going to show all three for every problem, as that would take a long time, but what I'm going to do is I'm going to identify for you the percent, the part, and the whole so that we can see how to use a diagram to set it up. So you can use whatever diagram you want, and then you should just check to see how yours compares to mine. So our first problem is, what is 80%? So here we do know we have our percent here of 50. So we want to find what that is equal to. So here's our of, which indicates this is our whole, and we're missing the part. So I'm going to go ahead and start our first one off with a tape diagram. So remember, I make 11 vertical lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then I box this in. Okay, to show our tape diagram. And we use a tape diagram like this because it's the whole piece. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. We know that the whole thing is worth 50. And we see that from here. The whole thing is worth 50. So if the whole thing's worth 50, that means each piece is worth 5. And the other piece that I have that's missing here is, where are the percentages? Well, each one of these parts of my tape diagram are the percentages. So this indicates 10%, 20%, 30%, 40, 50, 60, 70, 80, 90, and 100%. And again, 100% is equivalent to 50. So I want to know what 80% is, so I come over here. This much up to here is worth 80%, so I count. 5, 10, 15, 20, 25, 30, 35, 40. So 80% of 50 is equal to 40. Part of the reason that I chose the tape diagram is I noticed that this was a nice percent that ended in a 0, and this shows this very well. For this problem, I'm going to go ahead and use a ratio table to solve. And the reason I'm using a ratio table is I see that this is 25%, so it's not a nice 0 on the end that like a tape diagram could solve. Plus, I want to show you a different way. So what is 25%? So here I have the percent of the whole amount is going to be equal to the part. So I set up my ratio table. And in this case, I'm going to compare my number to my percent. Since the whole amount is 140, that's going to be equivalent to 100%. And my target is to find 25%. So I could go ahead and I could divide by 2 to get to 50%. I could divide by 2 to get to 70. And again, I see here I can just divide by 2 again. Divide by 2. And my answer is 25% of 140 is 35. Okay, this problem is 10% of a certain number is 16. So here again I have my 10% of my whole amount is missing. And is, this is another word to say equals, is 16. So this is my part. So I'm going to go ahead and use a double number line to solve this one. Again, we are going to go ahead and compare the number to the percent. And in this case, again, remember we start out with, we have 0 and 0, and then we all have 100 over here, and 100 is going to go on the percent down at the bottom. I'm missing the whole thing, so I am missing what goes on top of the 100%. What I do know is 10% is 16. So I'm going to come over here and I'm going to put 10% on the bottom is 16. And I'm going to move my way to find my answer. And this one's really easy. I could just do times 10. Most of us know 10 times 10 is 100. So I do 16 times 10 to get to 160. So my missing piece is 160. So 10% of 160 is 16. Okay, 40% of a certain number is 28. So here again we have our percent of the whole amount, we're missing the whole, is the part. So I'm going to use a tape diagram to solve this. Box it in. Okay. And again, remember the whole thing is what's missing. So I'm missing what this whole piece is. So I'm going to put a little question mark down here. And then I have 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. and I know 40% is 28. So here's 40%. So up until this point is worth 28. Well, there's 4 equal pieces. So if I do 28 divided by 4, I get to 7. So everything's now worth 7. And you can see here 7, 14, 21, 28. So 40% is 28. The whole thing is going to be worth 70. So 40% of 70 is 28. This says what percent of 30 is 24, so we're missing the percent piece of the whole amount is equal to the part. So I'm going to go ahead and set it up with a ratio table this time. And this time my comparison is going to be part to whole because I have those two numbers. I have the part and I have the whole. So I have 24 and I have 30. And I'm trying to find the percent. We know that part of the whole is always out of 100. So 100 is my target on the bottom. So I'm going to go ahead and start my diagram by dividing. And I'm going to divide by a common factor of 6. I'm going to divide by 6 top and bottom. 24 divided by 6 is 4. 30 divided by 6 is 5. From here I'm going to go ahead and double it. And then I get 8 and 10. And now I can see that 10 goes into 100 10 times. 8 times 10 is 80. Any number out of 100 is the percent, so my missing percent is 80%. So 80% of 30 is 24. Okay, this one says what percent of 150 is 18? So again, we are missing the percent of the whole amount is the part. So I'm going to go ahead and set up on a ratio table, which is really the easiest tool to use for this type of when we're missing the percent. So again, I'm going to do that part to whole comparison. And I'm going to do 18 to 150. And we know when we're talking about percents, it means out of 100. So that's a part to whole comparison. So we'll put 100 here. And so now I'm going to go ahead and start to simplify. I'm going to divide by 2 first. So I get 9. Divide by 2 makes 75. I'm trying to find something that's going to go into 100. So I'm going to go ahead and divide by 3. And I'm going to divide by 3. Which makes 25, and now I can just multiply by 4 and multiply by 4, which makes 12. Any number out of 100 is the percent, so 12% of 150 is 18. Okay, this problem says concert tickets are 25% off. What percent of the original price will you pay? Your understanding of this is that when you are discounted a certain amount, so let's say it's discounted 25%, okay, so we'll call this the discount. Just going to abbreviate, plus the amount you pay, okay, is going to have to equal 100%. So when I look at this, if I'm looking at 25%, well, 100 minus 25 makes 75. So the price that I'm going to pay is 75%. Keeping this in mind, when we go to find the original price, we're always looking for the amount that we paid. Okay, since we have a word problem in front of us, we're going to use our reading strategies of reading this 3 times. First, we're just going to read it once, then we're going to go ahead and mark it up, and the third time we're going to read it for its purpose. A pair of pants sells for $52. If the sales tax is 7%, what is the total cost of the pants? So if a pair of pants sells for $52, that means that that is the total price or the whole price. So this 52 means the whole. If the sales tax is 7%, so here I have the percent. I'm looking for the total cost of the pants. So I know right from these 2 pieces that I am missing the part. I go back for my purpose. What is the total cost of the pants? When you go to the store and you have sales tax, the sales tax gets added on to the price of the item. So when I'm finding this 7%, the 7% is going to indicate the sales tax. So I'm going to go ahead and set up a double number line to solve. And this time we're going to compare our percent, which is our sales tax, I'll label that over here, to our amount, which is the amount of the sales tax. If I get charged 0%, that means I don't pay any sales tax. If I get charged 100%, that means I have to pay $52 in sales tax. Since 7% is really close to 10%, I'm going to go ahead and find that first. And the reason I didn't put 7% on there because I don't want it to get too confusing in there. So we're going to find our 10%. So that's dividing by 10. And I'm going to have to divide 52 by 10. And I know that in the number 52, the decimal comes at the end. Once I divide by 10, I move the decimal one place to the left. So 10% is $5.20 sales tax. Okay, so here I'm still thinking, well, how do I find 7%? Well, I have to find 1%. So I'm going to divide by 10 again. We're going to find our 1%. So I'm going to divide by 10 again. And remember, dividing by 10 is just very easy to do. Divide by 10, which means I'm going to move my decimal one place to the left. So that means 52 cents. So in this case, in order for me to find 7%, that means I'm going to have to go ahead and multiply by 7. And this, if you needed to, you could use a calculator, and I'm going to multiply by 7. Or it's just like doing this. You take 52 times 7. That's 14, carry the 1, 35, 36. But we know that 7% can't be $364. So what makes sense is we would put it in here at $3.64 because that makes sense on our number line. So if I have a $52 pair of jeans and I have to add on, because remember this is what we found was the sales tax, I'm going to add on $3.64. My total cost would be 52 plus 3 is 55 plus the extra 64 cents, so I would pay $55.64. And again, this is your sales tax. That was your 7%. An MP3 player usually sells for $150. It is on sale for 20% off. What is the sale price? So if it sells for this amount, that means this is the whole thing. If it's on sale for 20% off, that means I have my percent, which means I'm missing my part. So the discount is going to be my part. And they're asking me for the sale price. So I have two ways that I could solve this. I could figure out 20% of 150 is equal to what? That would be my discount. Or I could find 80% of 150, and that would be equal to what I pay. Okay, so both of these are finding the same thing. We're both missing the parts. So I'm going to go ahead and show you on a tape diagram how this can be solved in one step. Okay, making my tape diagram here. These are all my percentages on the top. And I know my whole MP3 player is worth $150. So if this whole thing is worth $150, I want to find 10%, I divide by 10. So each piece is worth 15. And my first one says if I find 20%, that means I'm finding the discount. So if I look here, 20% of it is $30. So that would be my discount, $30. So I would have to take it one step further and do 150 minus the $30 would equal $120, and that would be my sale price. So this over here shows my discount. So opposite of that is what I pay. So here's my 80%. And if I just count it up, well, 15 and 15 is 30, so two groups are 30, so 30, 60, 90, and 120. So you would pay $120, and you can do that in one step with the tape diagram. GameStop was running a deal. If you bought 2 games, you got 20% off the original price. Your discount was $20. What was the original price of each game if they cost the same amount? So let's go back and reread. So here's my percentages. So they've given me that information. They tell me what my discount is. My discount is always my part. So in this case, I'm missing the whole amount. So if I set it up, I can set it up as 20% of a certain number equals $20. Okay, and I'm looking for how much they pay. So in reality, if I'm looking for how much they pay, I probably want to look at what the 80% equals. So since I can do this comparison, it's very easy to do on a tape diagram, excuse me. So let's go ahead and set that up. And if I set it up like this, I don't know the whole thing. So in the ratio tables or the double number lines, you would be missing the number above the 100. What I do know is 20% is 20. So here I'm going to go ahead and put my percents up here. Oops, I missed one. 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll just add an extra one on the end here for 100%, which we don't know. So again, in that ratio table, wherever you have, if you're doing your number to percent comparison over the 100, there's nothing there. Your comparison is 20% to $20. So I know 20% is $20. So these two pieces together make $20, so each piece has to make 10. So the whole thing then is worth $100. So if I'm looking at how much I paid, since this is a 20% discount, I take off $20 from 100, so I could do 100 minus the $20. So that would mean that I would pay $80, or what they charged me. Or I can, I shouldn't say pay, that's what the original price was. Or I can look at the other side of the 80, with the 80% here, because this is the discount. And this is what you'd pay, 10, 20, 30, 40, 50, 60, 70, 80, and it works out. So the answer here is it would be $80 for two of them, or $40 for one if you wanted to take it that far, because I would divide it in half. Okay, there are 30 students in math class, and 40% of those students are girls. How many boys are there in class? So what I'm looking at, if there's 30 students in class, that's the whole amount. And 40% is our percentages, but this is for girls. We want to know how many boys. So if 40% are girls, that would mean 60% are boys. And you could use either one of those to start. So I'll go ahead and show you how to figure it out with knowing that there's 40% girls. We're going to go ahead and use a double number line. And again, this is 40% of 30 is equal to what number? Okay, so here's our double number line. And we're going to compare it, our percent, to our number. And we know that if there was 0% were girls, that means there would be 0 girls. Or if there were 100% of the students were girls, it would be 30 students. But we want to know 40%. So we're going to go ahead and divide by 2 to find our 50%. Divide by 2 makes our 50%. So if half of the kids were girls, there would be 15 girls. And then since I have 50, I can go down to 10. So I'm going to divide by 5. So if 10% of the class was girls, if I divide by 5 again, that would be 3. There would be 3 girls. But I know that 40% of the 30 are girls. So I'm going to go ahead and move it backwards and do times 4. So here's 40% times 4. And I'm going to do 3 times 4 is 12. So 40% of the girls are, 40% of the 30 students are girls, so there will be 12 girls, but we want to know boys. So if there are 12 girls, we would do 30 minus the 12 girls would be equal to 18 boys. Or if you wanted to use the 60%, from here, if I have 10%, I could just go on to the other side of 50 and do 60 by multiplying 10 times 6. And I could use 3 times 6 to get to 18 boys, and I still found the same answer just in one step. So you can utilize the other percent that goes with it, because if there's 40% girls, that means there's 60% boys. So our answer is 18 boys, because that's what the question asked us to do. There are 500 sweets in a box, and Mrs. Miller gave out 35% of them as prizes. How many are left in the box? So if there's 500 sweets, that means that's a total amount, so that's whole there. And we have our percent. And if I go back and take a look, so that means I'm missing my part, it's asking me how many are left. So if 35% were given out, that means 65% were left. So you could use either one of those ratios. So I'm going to go ahead and set it up in a ratio table, and we're going to go ahead and do a number to percent comparison, because I'm missing my part. So this would be set up as 35% of 500 equals, and that would be candies. These would be the amount for prizes, so they were given out. Or you could do 65% of 500 would be what's left in the box. So we'll go ahead and use, I'm going to use a 65% this time. So I know that if I have 100% of the chocolates in my box, that's 500 pieces. And I want to know what it means to be 65% because that's how many is left. So I'm going to go ahead and use my ratio table strategies. I'm going to go ahead and divide by 10. Get these numbers a little bit smaller. Divide by 10. And that would give me 10 and 50. And I'm also going to divide by 5, and you'll see, divide by 2, so I can get to 5, because I need that 5% on the end. So I'm going to divide by 2. There it goes again. 25 here. So if I had 5% of the candies left in the box, that would be 25 candies, just so we know how to read our table. From here, I'm going to go back to the 10, and I'm going to multiply by 6 to get to 60. And I'm going to multiply 50 times 6 to get to 300. I need 65, so I'm going to add together 60 plus 5 to get to 65. So I'm going to add together 300 plus 25 to get to 325. So that's how many candies are left in the box. 325 candies left. Now let's say perhaps you didn't use the 65 but you used the 35, so we could make that as well. I can use my target as 35, so I'll put that here. It's 35%. So if I go from 10 times 3, I get 30. So I go on the top, 50 times 3 is 150. And then I would add together the 30 plus the 5 to get to 35, and I'd add together the 150 plus the 25 to get 175. So this 35% would be 175 of the prizes were given out. And here's a quick check that you can do. If I have 325 left, plus the 175 given out, when I add it up, it makes 500 altogether. So you did the problem right. Sarah's completed 28 kilometers of a 40-kilometer fun run. What percent does she still have to run? So as I look at this problem, I can see that she has completed 28 of the 40 kilometers. So this is part of the whole amount she's completed, and I'm missing my percent. But I'm going to go back and look at the purpose of my question. I want to know how much she still has to run. This is what she completed. So there's a couple key words in here. So I can set up one of two number sentences. And I'm going to use, it's blank percent of 40 is equal to 28. And this number sentence stands for, and I'm going to put a little C in here for completed. She completed this percent of 40 to 28. What is it? Then I have another number sentence I can use. So percent of 40 equals 28. Equals 12. And the reason I'm using 12 is because this is how much she has left to run. So I'm going to put LR percent for left to run. If I add together 28 plus 12, I get 40. And that's the total amount. So I'm going to go ahead and start on the original one. And I'm going to use a ratio table to solve, and because it's easier to find percents in this. And I'm going to do a part to whole comparison. And what I have is, this is my whole amount, this is my part amount. So 28 out of 40. And when I find that percentage, because we know percentages that are out of 100, that's going to be what she's already ran. So we're going to title this one the C for completed. So I'm going to go ahead and work my table. I'm going to divide by 2 to get 14 and 20, and the reason I did that is because I know 20 goes into 100, so I always try to find numbers that go into 100. So 20 times 5 makes 100, 14 times 5 makes 70. So she completed 70% of her run, which means 30% is not complete. If we use the other one where she's got left to run, or not completed, and we do a part to whole comparison, watch what happens here. This time we're going to compare 12 to 40, because this is what she has to run, and we still have 100 here on the bottom. So I'm going to do my same procedure here. I'm going to divide by 2 to get to 20. I'm going to divide by 2 to get to 6, and then I'm going to multiply by 5 and multiply 6 times 5 for 30% not completed. And this is my answer that I needed to answer this question. Mary has a glass bottle collection. She has 16 bottles made of blue glass. This is 20% of her collection. How many glass bottles does she have altogether? So I know she has 16 bottles that are made of blue glass, and that's 20% of their, and this word altogether indicates that this is the whole amount. So 16 would be our part and 20% would be our percentage. So when I write this, we'd have 20% of a certain amount has to equal 16 because we're missing the whole piece. So I'm going to go ahead and use my tape diagram to solve this, and I'm going to show you how it would work. 5, 6, 7, 8, 9, 10, 11. I'm going to set it up here. And again, I'm missing the whole thing, so I have a question mark here. Each one of these is my percentage. And what I know is 20%, and remember this equal sign means is 16. So if I have 20% here, these two equal pieces make 16. So each piece has to be worth 8. 8 plus 8 makes 16, which makes our 20% of our collection. So everything has to equal 8. So 8 times 10 is 80. So her whole collection is 80 pieces. If I'm using a ratio table or a double number line, the number above the 100 is what's missing. And at the 20% mark, you would compare that with 16.